That's there. My screen got really dark for some reason. All right, let's start off with an attendance note. Let me know you're here. So I posted an announcement last night about slip days, and the only point of that announcement is if you're planning to use a slip day for PA4 or PA5, let me know ahead of time. Send me a note to my regular email address before the due date, because what I'm finding is happening is I'm downloading and grading assignments when in fact the student's planning to use a slip day. And I don't know that, so I grade it and I debug their code and write some comments and so on, and then it turns out they want to use a slip day. So let me know ahead of time before the deadline. Okay, once the deadline hits, if I don't have a note from you saying that you want to use a slip day, I'm going to go ahead and grade it as the final submission. But slip days are there for your benefit, right? So if you want to take an extra day or two or three or four, right, for an assignment, you don't need to ask permission. You definitely don't need to apologize or feel bad about it or anything like that. They're there to help you out, right? If something happens and you can't get something turned in by the original posted deadline. So feel free to use these, you know, in whatever way makes the most sense for you. All I'm asking in that announcement is send me an email, right, to my regular email address before the actual deadline, so that I know when I download the submissions at the deadline point not to pay attention to yours until, you know, the given number of slip days has passed. And if something is due Friday morning at 8 and you send me a note Thursday night and say, okay, I'm going to use a slip day, right, then it's due Saturday morning at 8. And if, you know, Saturday morning at 2 you decide you need another slip day, just send me another note and say I want to use a second slip day, right? And if you need more time, you know, Saturday night, send me another note saying I'm going to use a third slip day. That's totally fine, right? As long as you have the days banked, you can use as many of them as you want for any assignments, any of the programming assignments you choose. Just tell me before the deadline. Does that make sense? All right, so let's look at ODP 415. I'm really wondering about my screen. It's charged. Very strange. So 415, you're writing a function, okay, same as we've done in others. Your function is called calc, C-A-L-C. It takes a single argument, which is a char star, which means it's a string, which means it's an array of characters. And so you want to declare your function when you're writing it as taking an argument, call it whatever you want, but the type of that argument should be a char star. And the function should return an int. And the behavior of the function is to basically interpret this as an arithmetic operation that you want to perform. So char star should be a string containing a number, a symbol, and another number. These numbers are integers. The symbol should be a plus, dash, asterisk, or slash to indicate addition, subtraction, multiplication, division. And your function should return the value of doing that operation. All right? And you don't need to do a whole lot of heavy work to break your input string into these pieces. Okay? you should do that using scanf with the pattern %d, %c, %d. And that's really the only way you should do it. If you do anything else, you're making your life a lot harder, and you're potentially, going to do things that won't get you full credit. So use scanf with that pattern, and you should end up with, a pair of numbers, integers, and an operator. If you can't parse it successfully, if scanf doesn't recognize this pattern, just return -1. If it does recognize this pattern, but the character that it matched the operator is not one of these, then you want to return -2. Otherwise, you should do whatever the operation is on whatever the two numbers were, and then return the result of that calculation. So just as some examples of what your function should do, if you passed it these strings, these are the results, and the angle brackets are not part of the string, right? So you just pass it a string containing 3 characters. 9 plus 9, your function should return 18. 9 equals 8, it should return -2 because equals is not one of our recognized operators. Ha plus ho should return -1 because this is not an integer. This is a test should return -1 because this is a test is not an integer. 2.3, well, that's a pair of integers separated by a character, but that character is not plus, minus, times, or divide, return -2. Right, 121 plus 2, 3, 4, 5, 6 should return this number because that's an integer. An integer, this is a plus operator, it should add these numbers together and return their sum. Alright, so you want to write your function to do this, and then test it with your own main program, and once you're sure it works, go ahead and link it with the test bed like that, and then assess it. And there's a single test, you want to get 10 out of 10 on that test. Alright, so how do we do it? Something like 7 minus 8 would return -1. Yeah, that's an error code too, but that's okay. Yeah, I did an attendance ping, so go ahead and send me your attendance note if you didn't do it already. And this is an ODP that just opened today, so it's due tomorrow. So yeah, let's talk about how to do this. So you're going to declare your function. Whatever you want to call it. So let scanf do the hard work for you. So scan your string and then use this pattern %d, %c, %d. No spaces in there. And then this %d will match our first number, so that's going to go into something called num1, which I'm going to declare as an integer, along with num2. And this %c is going to match a character. Alright, so single character is just like a single integer. We're going to need a name of a character variable. So I'll call it operator, OPR. And this will be address of that operator. And then I'll do address of num2. Alright, so this will do all the hardest part of the parsing for you. Right? It will look at the beginning of your string, it will gobble up as much of that string as it can that represents an integer. So if your string is something like 21 plus 2, 3, 4, 5, 6, the 1, the 2, and the 1, those will all get gobbled up by scanf, and those will get dumped into num1. And when it got to the plus sign, it'll say that's not part of an integer, so it'll stop. So the %d matches 121, goes into num1. Now it's going to look for a %c. That's a single character, and it's going to find this plus sign. That's a character, so that character will get saved in this character called OPR. And then it's going to start looking for an integer. And it's going to find the 2, the 3, the 4, the 5, and the 6, and that'll be the end of the string. So all of that will get matched to this %d and dumped into num2. So if that all works, num1 and num2 are a pair of integers, OPR is the thing you want to do to those integers. But how do you know if this actually found an integer, a character, and an integer? You got to check the return value. And if it matches an integer, a character, and an integer, it will load values into here, here, and here, total of 3 values. So if return value is not equal to 3, that's a parse error. So what do we do if there's a parse error? If you cannot parse the string successfully using this pattern, return -1. So there you go, return -1 and you're done. But if it does find an integer, a character, and an integer, return value will be 3, so now we can go ahead and try to do whatever that arithmetic operation is. But what we're going to do depends on the value of OPR. Well, you can just use a set of if statements if you like. You can use a switch statement if you like switches and so on. So we could do something like if this operator is a plus, then what do we want to do? We want to add your two numbers together, num1 and num2, so we could return num1 plus num2. If your operator was equal to a minus, then we want to return num1 minus num2, and so on and so forth. And if it doesn't match any of these, that's another error. That's where we return -2. And -2 is the value saying that we parsed it successfully. scanf returned 3, but the operator was not plus, minus, star, or slash. So this does not have to be a lot of code, right? And in fact, it probably should not be a lot of code if you're doing it the way I envisioned. And looks like we got lots of 10 out of 10 so far. All right, questions about that? All right, let me make a brief comment about winter terms. So I posted a survey a few days ago asking about people's preferences and requirements for winter term. And this basically involves CSE215 and CSE222. So CSE215 is discrete structures. If you're taking it now, you don't have to listen to what I'm about to say. But if you have not taken CSE215, if you're not taking it this quarter right now, and you're planning to transfer to WSU in fall, you've got to have CSE215, right? It should be on your plan of study for either fall or winter. And if you don't take it in fall, you got to take it in winter. All right, there were 3 people in this class who said they needed more information to know whether they were going to take 215. Send me an email if you're not sure about this, right? But it should definitely be on your plan of study, and if you didn't get it in fall, take it in winter. Winter is going to be in person for 215 because fall was remote, but lectures will be recorded and posted, and hopefully we'll be Zooming them live if the technology in the STEM building is up to it. So if it's streamed live, right, you should be able to take the class remotely even though it's meeting in person. But if you have any questions about that, or if you're not sure, you know, if you need to sign up for this, definitely send me an email. Because if you're planning to transfer to WSU in fall and you don't take CSE 215, You won't be able to take some third-year classes. You'll end up needing another year after you transfer. You don't want that to happen. All right. The other question was CSE222, and it sounded like a grand total across two sections of 8 people felt like they preferred having this be face-to-face. So there's definitely going to be an online section. There'll be an in-person section, but the in-person section will be capped, probably at 25 students. So if you really want the in-person section, make sure you register as soon as your registration opens up. And again, those in-person classes should be recorded and posted and hopefully zoomed live, depending. And I will overload both of these to admit everybody who wants to come into them. But 222, I won't overload the in-person class. That'll be capped at 25. Everybody else will go into the remote section. All right, and thank you for doing the survey, those who did, because that definitely helps, having that data. All right, so I wanted to pick up a few other Unix commands here before we start digging back into aspects of C. So, first command I wanted to talk about is tar. And tar is short for tape archive. It was a utility originally that you could use to take a bunch of files and throw them onto a magnetic tape. And magnetic tape is a peculiar way to store information because it works really well if you write and read it in order from beginning to end. But it doesn't work well for random access, right? So you sort of go through from the start to the end. Tape is pretty efficient. So tar is a utility for turning a bunch of files into one big long file that we call an archive, or a tar file. And there's a gazillion options for tar, so you can look at the manual pages for it. And you know, there's switches galore that you can put on this. I'm going to show you 3 specific tar commands, and these are probably the only things I've ever had to do with tar. Doesn't mean the other ones aren't useful, but these should get you most of your behavior. So the 3 commands are tar CVF, tar TVF, and tar XVF. And tar is a little unusual. There's no hyphen in front of these switches. It's the only command I think I know in Linux that doesn't have a dash there. So tar CVF, this is how we create an archive file. And the idea is we might have a whole directory of files that we want to make a copy of into a single file, so that we can take that one file, save it on a flash drive, send it to a friend, put it on another machine, something, right? So CVF is how we create such an archive. And this is the most error prone of the 3 commands. So tar CVF has to be followed by the name of the file you're creating. So this is followed by tar file name to create. And then it's followed by a list of files or directories. So tar CVF, the name of the file you want to create, and then a list of the things that you want to put into that archive. So let me pick on, let me just go to the server. So here's my tools area. And I have a number of directories under here and a couple of files, right? So I have an admin directory where I do administrative stuff. This is my tool set for adding new students, you know, creating new user accounts, cleaning up accounts at the end of the year, and so on and so forth. I have this QA directory where I have a utility for doing questions and answers online and so on and so forth. So I have all this stuff, and I have a few files in here also. And let's say that, you know, this directory, which is called tools, let's say I want to make an archive of that. Alright, so I'm going to use the tar command. So I'm going to say tar cvf, followed by the name of the archive I want to create. And so I'm going to make an archive in my home directory. I'm going to call it toolbackup.tar. And then I could list all the files I want to put in this archive. Well, I'm just going to say dot, which means I want to put in my current directory, and tar by default puts in all the subdirectories as well. So I'm going to say tar create an archive named this, containing my current directory and everything underneath it. And when I do that, tar spits out a list of all the things that are going into that tar file. So it shows me it added a file called Java Run, it added a directory called QA, it added all these files under the QA directory, it added an archive directory under QA with all of these files, it added a backup directory under archive, and so on. It added these other files in the QA directory, and then it added a .git directory because QA is under Git control, so all of my Git files got stored, and so on and so forth. So if I look in my home directory, I have a new file now called toolbackup.tar. It's 481K, and this is an archive of that entire directory tree. Alright, so the next command, tar tvf, just takes one argument, which is the tar file name that you want to list. Tar tvf shows you the table of contents of a tar file. So if I say tar tvf tools backup, toolbackup.tar, that shows me everything that's in that directory, that's in that archive. And if I pipe this into more, I can look at it one page at a time. And it looks like, you know, an ls-l. So it's showing me, you know, the file name, the permission bits, the type of file it is, the owner, the group, the size, the creation or modification timestamp and date, and so on. And all that information is preserved inside this one tar file. And so that file, you know, if I try to VI it, it's well, it should be gibberish. If I cat it, it's stuff, right? Some of it is readable, but some of it has these strange things in it, and stuff like that, and this kind of stuff, right? So this tar file is not meant to be edited. It's not meant to be modified by us. It's like a binary file, even though it has stuff in there that we can actually read. Alright, so that's the archive we created. And the last command is tar xvf. And here you take one argument, which is the tar file, to read from. And I can say tar xvf, the name of a tar file, and it will reproduce that directory structure contained in that file. So for example, I'm in my home directory. I could make a new directory like this. There's nothing in there right now. I can say tar xvf /toolbackup.tar, and it extracts that entire directory tree into my current directory. So now I'm in my new directory, but I have all of these directories under here. I can go into QA, and there's my whole directory there. And in fact, I can do git status and see the status of my git repository, and so on and so forth. And this is just a plain file, right? So for example, if I wanted to make a copy of my tool directory onto my Linux machine, I could do the following. I could go into my 224 directory. I could go into a tools subdirectory, which is empty, and then I can copy this toolbackup.tar file from the server to my local machine. Now if I'm on Windows, I might do WinSCP to copy that file down, but I can also use SFTP, so the Secure File Transfer Protocol. Put in your username at the host, and it'll ask you for a password unless you have, authentication set up. And now I can run commands on this remote machine, linuxengrcs.com, from this utility. So if I say ls, it shows me the files in my home directory on this machine. I can do an ls-l and see, oh yeah, tool backup, that's the file that I want. If I want to copy a file from that machine, I just say get. So I can say get toolbackup.tar, and it'll fetch it from that remote machine to my local directory. And, it fetched 470K in about 1 second. And you can do all kinds of things in FTP. You can also do puts. If I have a file in my local directory that I want to push to the remote machine, I can say put. And if you say help, you can get a quick synopsis of the commands that are available. And you can do a lot in FTP. You can also do things like run commands on your local machine. So if I do LLS, that'll show me the results of doing ls on my local machine in my laptop. If I do ls, that shows me the result of doing ls on the remote machine. Alright, so I've pulled this toolbackup.tar file over to this directory. Now if I just tar xvf, I've got a clone of my entire repository, my entire directory structure on my local machine now. So I'm in my tools area, and I can go into, admin, and there's my code in the admin area. And doing an xvf does not change the tar file, right? This is still intact. It doesn't remove anything from there. It just pulls a copy of your directory tree out of that file. So, I could copy this somewhere else and make another copy of my directory tree. So that's the tar command. A command you'll see similar to tar is gzip. And gzip is just a compression utility. And basically you can just say gzip any file and you'll get a compressed version of it. So let's make a my file. Alright, so here's my file. It's 216 characters of poetry. If I want to compress that into a smaller size, I can say gzip my file. And now if I look, my file .gz, that's the zipped version, is only 64 bytes. So it squished it down to almost a quarter of its original size. Now if I try to look at my file .gz, it's not readable anymore. Right, it's compressed. But I can unzip it by saying gunzip. Put that name in, and now I'm back to my original my file. So it's not very different from zip, unzip under Windows, right? You can do it from the command line. And it's usually done with tar files because this tar file, right, is 481K. If I zip that up, that'll shrink down to 79K. So pretty significant space reduction. And sometimes you'll see files with an extension of .tgz. That's just a more succinct version of a .tar file that's been gzipped. So sometimes these are renamed to that, and that's affectionately called a tarball. Alright, last command I want to mention in this batch is find. And find is a useful way to search for files in Linux. So let's say I'm in my CSE224 directory. If I just want to see all the files that are contained from this point down, I can just say find period. Remember, period means my current directory. So find space followed by a period will list all the files starting with my current directory. And so I can see, you know, a list of everything from this point down in my directory tree. But you can also use wildcards with find. So you can say find period, but you can also say find period dash name, and you can put a pattern in here which can include wildcards. So if I wanted to list all of the .c files in my directory tree, I could say find dot dash name quote star .c, and any file that ends with .c in its name will show up in this list. So it's just the stuff in my PA3. If I did a find dot dash name star C star, this will show me any file that contains a C anywhere in its name. If I want to look just for git stuff, I could just look for star git star, and there's the files that contain git somewhere in their name. And find is, you know, a probably bigger utility than tar, so a huge number of options. And you can use find to do all kinds of sophisticated searches. You can search for files that were updated, you know, between 24 and 48 hours ago, and have a name that matches this pattern, ignoring uppercase, lowercase differences. And when you find one of these, I want to do some command on it, like copy it somewhere else, right? So this is a whole little universe in itself. But you know, almost without exception, the only thing I've had to do with find is just this. It's just really good for looking for wildcards, and it's fast, right? So you know, this is my main directory tree, which is a few hundred gigabytes, and if I just search for files named .c, it takes almost no time, right? And it's gone through the entire directory tree. So super efficient. All right, questions on any of that?
Can you show your page again?
Yeah.
So tar doesn't compress on its own. It's
tar does not compress. Tar just makes an archive, and then we usually follow that with a gzip. And I think there's a switch you can put on tar which says go ahead and gzip.
So I guess tar is specifically for like converting it to magnetic paper tape or something, whatever those are called.
Yeah. So AR is an archive utility. Tar is a tape archive utility. So I don't know if they still call it that. Yeah, they don't really refer to the tape anymore. But yeah, it's really made for simply taking a collection of files and storing the information about them and their relationship in a directory structure. A lot of Unix mentality is sort of like single function focused, because we have the ability to pipe things together and write scripts and so on. The core behavior of a lot of things is sort of single function, but pretty good bet that we can compress. So we can filter the archive through bzip or lzip or gzip and so on and so forth. The disadvantage is if you're making a really big archive, you know, one that's like 30 gigabytes, you may not want to spend the energy to zip it up, right? You may want to make the archive first and then do something with it. So you have the option to do them at the same time or separately.
Yes, Dash J is obviously intuitive with gzip.
Yeah. So this is what I do at the end of the school year. Before I delete all the student accounts, I make one big tar file of it, and I throw it up on GitLab. And then if a student comes back to me, you know, 3 years later and says, you know, I really need that program that I wrote, you know, 3 years ago. Is there any chance you have it? I can go back and I can pull it from a tar file with a little bit of work. All right, let's go ahead and do an attendance ping. Make sure people are awake. It's getting kind of quiet. All right, let's talk about everybody's favorite, the car star. And so this is a gear change here, right? So I want to start looking at some C stuff, and I want to think about strings and characters and arrays of characters and arrays of strings. And this car star business that we see when we make a main program, I want to start to try to understand more clearly what's actually going on with that. And so let me start with 3 types of declarations. Right, we have these 3 things that we encounter sometimes: char C, char star S, and char star argv. The name of the variable is meaningless, right? I'm just using these because they're kind of more typical of what we do in code. But this first one is very straightforward. This is really no different from saying integer I or double X, right? We're declaring a single character. Characters are a single byte. And we're saying, hey, compiler, I want to have a variable named C. Can you find somewhere to store that for me? And so I'm going to draw a kind of bogus memory map. And you know, the memory of your computer, we can pretend that it starts from memory location 0, even though it doesn't. And it might say, you know, the compiler and the linker together might huddle up and say, okay, we're going to store this character C right here at location 4. And so if I say C equals single quote H, then memory location 4 will contain the ASCII code for the letter H. And you know, if I say integer I and it decides to store I at location 2 and I say I equals 17, then memory location 2 contains a 17. So that's pretty direct, right? There's a location dedicated to this variable. In this example, it's location 4 in memory. And whatever C is equal to, you'll find that value at that location in memory. It gets a little more interesting with a char star. Thank you. So a char star S, for example, there's 2 things going on. The first is we have to store S itself somewhere in memory. And so S might be stored at, I don't know, maybe location 10. So let's say at location 10 it stores S. But what is S? What kind of thing is it? It's not an integer. So what kind of information is stored in S? S is a pointer. And a pointer is really just an address. So S should store the address of something. right? This tells you it's storing the address of something. This is the kind of something it's storing the address of. So S is the address of a character. So S might be equal to, 144. And down here at memory location 144, there should be a character. And if there's a second character in our string and a third character in our string, those will be stored at the next locations in memory. So if S was equal to, quote, hi, alright, if S is stored at location 10, at location 10 we find the address of that first letter. If that's a 144, location 144 contains the character H. The next location contains the next character I, and the next location contains our null terminator. To say, hey, this string contains two characters, H and I. Now when we try to print the value of C, the print function is told, hey, print the character stored at location 4. The code for print looks at location 4, finds an H, prints it out. When we call print and we say, hey, print the string S, the print function is called with the value of S, which is 144. And at location 144, the print function will find the ASCII code for an H, it'll print out an H. And then it'll look in the next location in memory, find the ASCII code for an I, print out an I. And then it'll look at the next location, find a 0, and say that's the end of the string. And it won't print anymore. So that's the char star case. Now things get really weird when we have a char star star. So one way to think of a char star star is argv is a pointer, that's what the star tells us. It's a pointer to this kind of thing, a char star. So let's say argv is stored at location 36. I'm making these numbers up, obviously. So argv is stored at location 36, and let's say this contains the number 312. Okay, 312 is the thing that argv is pointing to. So if I go to memory location 312, that's what argv is pointing to. Well, what argv is pointing to is a char star. In other words, it's pointing to a pointer to a character. So what I might find here would be, say, a 200. And down here at location 200, there's a character. So if argv bracket 0 contained the string ABC, down here at location I would find an A, the next location would be a B, and then a C, and then an null terminator. Alright, so what's the poor compiler have to do to generate code to say, let's do something with argv bracket 0? Alright, argv is stored at location 36. Go to that location, see what number's there. It's 312. 312 is a memory location. Go to that location, see what's stored there. 200, that's where this string begins. So go to location 200, there's the character A, that's the beginning of our string, followed by a B, followed by a C, followed by a null terminator. Now if argv bracket 1 equals dog, well, how do we find argv bracket 1? We start with argv, it's stored here at location 36, it's got a 312. And at that location we find a pointer to argv bracket 0. In the next location, we'll find a pointer to argv bracket 1. and maybe that's got a 500 in it. So down here at location 500, that's where we find the first letter of argv bracket 1. So there's a D followed by an O followed by a G followed by a null terminator. So we can start to build this memory map, right? And it's a big spaghetti ball. It's pretty hard to work with as a human. The computer has no problem working with this, right? But basically argv points down here. This first thing points to argv bracket 0. This second thing points to argv bracket 1. So argv bracket 0 is right here, argv bracket 1 happens to be here for whatever reason. And at those locations I find a succession of bytes corresponding to the characters in each of those strings.
So in this example, argv is an array of strings.
Argv is an array of strings. But a string, remember, is a pointer. So argv is also an array of pointers. Right? There's the first pointer, there's a second pointer.
Okay.
Right? And that's a key concept right there. Right? The fact that there is no such thing as a string per se in C. There's only arrays of characters. And there's really not an array, there's really a pointer to an array. So an array of strings is an array of pointers, or memory addresses. So this is the super duper confusing way to think about this, right? But we're going to make it even weirder tomorrow. I want to run GDB and take a look at an actual argv array and see what this looks like in an actual physical memory map, right? And that will be a little horrifying at first, but it will help us to understand these concepts of pointers just a little better. And it'll be a good chance to play with GDB. You never want to pass up a chance to do that. And then this can gel for, you know, the next few weeks until we get to 222, and then we'll come back and do this with a vengeance. But I want to do an initial pass through this tomorrow, so that'll be what we start with. All right, send me an attendance note on the way out, please, and have a fantastic afternoon, and I will see everybody tomorrow.